Okay, here we have a question that isn't obviously of a familiar type because of this table of data. Do read through all this information at the top. You're going to need to come back to some of that later on. But the first part asks us to focus on the group 0.98 to 1.00. We've got volumes, groups, and then we've got frequencies. And part A1 is just to remind you that what we actually do is look at midpoints, but it wants the calculation you do with these two numbers that arises the midpoint of that for 1 mark, which is dead easy, but it's just a heads up for a later part of the question where you'll need to use the midpoint. And then for another mark, what values would round to this? You've got to look back here. It looks like that's the minimum and that's the maximum, but these are all recorded to the nearest 0.01 litre, and there are gaps between these because they have been rounded off. So 0.98 is not the lowest value that could end up in this interval. You need to think about rounding values off. So after that little starter, they get you to calculate estimates of the mean and the standard deviation. And of course we get those, if we've got the data, we put them on our calculator, and they've given you a hint about how to enter these ranges of values using these. And of course you put the frequencies in. You do this very carefully, you repeat it at the end of the exam if you've got time to get the correct answers for the mean and standard deviations. They're all B marks, you don't have to show any working if you've used your calculator. Then moving on, we discover what the question's really about. We've got to find a confidence interval for mu, so you use your recipe with x bar in it, with z in it, with sigma, if you've got one, or failing that, an s, and then an n. N's always easy. Z comes from the percentage and a normal distribution diagram, and your tables. X bar always comes from your data, and then you've always got to check carefully here. Only use S if you're forced to. Only use the sample standard deviation if the population standard deviation isn't available. Check whether sigma is available. If it is, use it, otherwise use S. But otherwise, this is 4 very easy marks for getting those 4 numbers and plugging them into your recipe. Then we've got to explain why the central limit theorem was not required. Not why it didn't apply, but why it wasn't required. That comes down to a little bit of theory. Your confidence interval recipe involves x bar, and the method is dependent on x bar being approximately normal. One reason why it might be is because the central limit theorem is being used. We know that's not true, so it's the other reason why x bar might have a normal distribution, and the clue is back at that top of the question, back up here somewhere. Okay, there's an important thing that you may have glossed over to begin with, but it's that you quote, and make sure you quote it in context. You actually describe what has a particular distribution. And then in the third part, why is the confidence interval approximate rather than exact? This can have different explanations in different contexts. The central limit theorem, if you're using it, leads to an approximately normal distribution for x bar, but we're not using it. So the other source of approximation rather than exactitude harks back to what we did in the table up here, because it was grouped data. So you can make a point connected to that. Finally, this is what they really like to do in the follow-up to confidence interval questions. They like to give us comments connected with a mean and with individual x values. You can tell this is about the mean because it involves the symbol mu, and for a comment about the mean, or a claim about the mean, you have to refer to the confidence interval, not the x bar value, the ends of the confidence interval, depending on whether one is in the interval or completely to one side or completely to the other. You may think it's possible that mu is greater than 1, likely that mu is greater than 1, or unlikely that mu is greater than 1. So the confidence interval is used for statements about the mean. This is a statement about x values, individual volumes. And for that, you have to go back to the data you're given. So the probability of x being between 0.94 and 0.16, you can estimate from the table. There's all the data. You can see what proportion of the data, and you should calculate what proportion of the data are actually in that interval, and then say either you do think it's approximately 1 or you think it's unlikely to be.